Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 9 in the Business Logic Vulnerabilities module titled Authentication Bypass via Flawed State Machine. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to go to Academy. Select all labs, do a search on business logic vulnerabilities, and go down to lab number 9 titled Authentication Bypass via Flawed State Machine. Alright, let's get started. This lab makes flawed assumptions about the sequence of events in the login process. To solve the lab, exploit this flaw to bypass the lab's authentication, access the admin interface, and delete Carlos. You can log into your own account using the following credentials, and they give us credentials. Alright, so the target goal over here is to exploit some logic flaw in the way the sequence of events in the login process is implemented, and then bypass the lab's authentication, access the admin interface, and then delete the Carlos user. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Okay, the first thing I'm going to do is log in with the credentials that we were given. So we clicked on my account, and the application is a little bit slow. We enter the username that we were given and the password that we were given, and then hit login. Now notice over here, when you log in, the first page that you're presented with is this GET request over here for the /role selector endpoint. And from there, you get to select the role that you are. So with this user, we have two options, either user or content author. So let's keep it at user and click on select. And we look at the post request right over here. Okay, the post request over here takes in two parameters, the role parameter and the CSRF token. The CSRF token is standard. However, the role parameter over here, that talks to the backend and could potentially change the role in the backend. And so let's see if it accepts anything other than user or content author. For example, let's see if it accepts administrator or admin so that we could change our privileges to an admin user. So let's log out. And then go to my account again and put in the username and password that we were given, hit login, and then set intercept to on. And then from there, let's say user, but when we get it in our proxy, let's make this a little bit bigger. When we get it in our proxy, we're just going to change this to administrator. So is equal to administrator. Click forward, and just turn intercept off and see if I could access the admin panel. So /admin, hit enter, and I still cannot. It says admin interface is only available if logged in as an administrator. So that didn't work. So let's go to my account and log out again. And I have one more item to try. So again, log in with the credentials that we were given, hit login. Now set intercept to off, click on select, and over here instead of administrator, let's try admin. Hit forward, and set intercept to off and see if that worked. So let's go to /admin. And we still don't have access to the admin account. All right, so that failed. So what I was trying to do over here is essentially see if this parameter over here is user controllable and not validated on the backend. However, it looks like it is validated in the backend, and that's why it doesn't allow me to put anything other than the options that we selected. Now there's one more thing that I could try, which is prevent the application from going to this request completely. So from requesting the /role selector endpoint and seeing what the application defaults to. Now, in some applications, there would be flaws in the way it's implemented where if it doesn't go to this endpoint, it will default to the privileged user, which would be the administrator user. And that's what we're going to try next. So let's log out. go to the proxy intercept tab, and then go to my account, reload it, log in with the credentials that we were given, hit login. And actually, I should have stopped the request from occurring before that. So you could see over here, it already performed this request, which is what I was trying to avoid. So let's redo that again. And this time we're going to set intercept to on. So we put in the username and the password that we were given, hit login. We forward this request. And so right now it's trying to get this endpoint over here. However, I want the application not to request this endpoint so that I could see what it defaults to. So what I'm going to do is I'm going to drop the request. And so over here you could see it tells me that the request was dropped. And so the next thing that I'm going to do is just load the main page of the application because I already logged in. So I should have a session in the application, and set intercept to off and see what role we've defaulted to. And the application is a bit slow, but this is already a good sign. So I could see the admin panel, which means that I've defaulted to the administrator user, and that's the flaw in the application. So now when we click on delete, we should be able to delete the Carlos user. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. As usual, the first thing we're going to do is import all the libraries that we need. So the requests library, the sys library, the URL lib3 library, and then from BS4, import beautiful soup, and then import the regex library as well. And then we're going to disable insecure request warnings. So URL lib3.exceptions .insecure request warning. Next, I'm going to set my proxy settings. So proxies is equal to all HTTP traffic should be sent to where burp is installed, which is 127.0.0.1, so localhost, port 8080. And then all HTTPS traffic should be sent to the same place. So again, 127.0.0.1, port 8080. All right, this looks good. The next thing we're going to do is define our main method. So we're going to say if name is equal to main, then call the main method, and we'll define the main method right over here. So we'll say def main if the length of the command line argument, so sys.argv, is not equal to tune, then print the usage instructions, so the name of the program and then the URL, and we take the name of the program from the command line argument, and then we'll also print the example instructions. So we'll say example, again the name of the program and an example URL, so let's say www.example.com, and the name of the program we take from the command line argument. Okay. Next, we exit the program because the user ran it incorrectly. All right, so let's assume the user did run it correctly. In that case, we create our sessions object. So it's requests.session. And then we create a URL variable, and we take that from the command line, so argv1. And then we call a function called delete Carlos that takes in the session object and the URL. And this function over here is a function that we'll define ourselves. So we'll say def delete Carlos, which takes in the session object and the URL. And in that function, the first thing that we need to do is log in because this is an authenticated vulnerability. And so if we go to our proxy and we go to HTTP history, let's look for the login request. Here we go. So it's a post request, it's to the /login endpoint, and it takes in 3 parameters, the CSRF token, the username, and the password. The username and password we have. The CSRF token is taken from the previous request, which is a GET request to the /login page. If we look at the response, you could see the CSRF token is right over here. And so what we're going to do is first we're going to retrieve the CSRF token. And to do that, we need to define the URL where we're going to retrieve the token, which is the login URL. So that would be the URL of the main application with the /login path. And then we'll create a new variable called CSRF token, which is equal to the return value of a function called getCSRF token that takes in the session object and the login URL. Okay, so this is a custom function that we're going to create that will retrieve the CSRF token for us. But before we do that, we're just going to add another comment saying rest of code here. All right, this looks good. Now let's define our CSRF function. So def get CSRF token takes in the session object and the URL. And we're going to say r is equal to s.get. So we're performing the get request to the URL. And then we're going to say verify is equal to false because we don't want to verify TLS certificates. And proxies is equal to proxies because we want our request to be sent to burp. And then we'll use the beautiful soup library. So beautiful soup. It parses the response r.text and it uses html.parser. And the way we're going to do that is we're going to create a variable called CSRF, and then we're going to use soup.find to find the CSRF token. So over here, if you look at the CSRF token, it's in an input element that has a name attribute that is equal to CSRF, and the value that we want is in the value attribute. And so to extract it, we're going to say, look for the input element that has a name attribute that is equal to CSRF. And then I want the content of the value attribute. And then we're just going to return CSRF. All right, so what that does is it extracts the CSRF token for us and then returns it. And so the CSRF token over here gets saved in the variable called CSRF token. All right, the next thing to do is log in as the user that we were given. And so we're going to print logging in as the user. And to do that, let's look at our post request. So it's a post method to the /login endpoint, and it takes in 3 parameters. We've retrieved this parameter, and now we want to add this parameter and this parameter, which we already have. So we're going to say data login is equal to username, which is just the username that we were given, password, which is again just the password that we were given, and then we've got CSRF, which is the CSRF token that we just extracted, which is saved in CSRF token variable. All right, this looks good. The next thing to do is just perform the request. So we're going to say r is equal to s.post, and that takes in the login URL. We're going to say data is equal to data login, and verify is equal to false. And then proxies is equal to proxies. All right, so the script by default, what it does is when it performs this request, it will follow any redirects. So you could see over here, this redirects to the /role selector endpoint that we saw allows you to select a role. However, the way we exploited the vulnerability is by not allowing the application to go to this endpoint, and so it defaults to the administrator user. And so what we need to do in our script to prevent the script from following this endpoint is add another parameter over here called allow redirects and set it to false. So what happens over here is that when it gets a 302, it won't follow the redirect and it won't perform this request over here. And so we will default to the admin user. All right, this looks good. So now that we've logged in and we've defaulted to the admin user, what we're going to do is we're just going to delete the Carlos user. So to do that, let's look at the endpoint that was responsible for deleting the Carlos user. So it's this one over here. It's a GET request. It takes in a parameter in the URL, which is this one over here, and we'll implement that right over here. So we're going to say delete Carlos URL is equal to URL plus the endpoint over here. So let's copy that. And then we perform the request. So R is equal to s.get. It takes in the delete Carlos URL, set verify to be equal to false because I don't want to verify TLS certificates, and proxies to be equal to proxies because I want my request to be sent to burp. And then we're going to save the response in a variable called Duraz. And we're going to check if we solve the lab by searching for the string congratulations in the response. Now, if we find it, and let's make this go up. So if we find it, then we're going to print successfully deleted the Carlos user. And if we don't find it, we're going to print could not delete the Carlos user. And we'll exit the program because clearly our exploit failed. All right, this looks good. So this is pretty much it. Let's reload the lab because it likely timed out. And while it reloads, we'll review the script. Okay, so over here, you could see the first thing that we do is call a delete Carlos function. In the delete Carlos function, it first logs into the account that we were given. And then from there, it prevents the login request from following the redirect to the role selector endpoint, which allows us to default to admin privileges. And because we have admin privileges, the next request that this function performs is it deletes the Carlos user. Hopefully, we don't have any errors in our script. So we're going to say Python 3, business logic flaw lab 9, and let's copy the URL, paste it in here, and remove the trailing slash, hit enter. So far, so good. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of a business logic vulnerability.